Hi, Chris Good here, and we're going to look in SPSS on how to use the nonparametric tests menu, and we're going to start with the example we did in class, which was the drug data. So here we have it here. We're measuring the back depression inventory scale on Sunday and on Wednesday, and we're going to, later on we're going to split the file, but right now I want to analyze all cases and do the Mann-Whitney U test. So we're going to choose independent samples because we're looking at the difference between folks who used alcohol and folks who used ecstasy, and we're going to choose independent samples from the menu and just skip right to the settings tab up here and click on Customize Test. Mann-Whitney U is the test that we want to pick because we're comparing two independent samples, and that's really all that we need to do. You could double check the test options and make sure that alpha is what you want it to be. You can select how you want missing values treated, but we're going to go with the defaults on this and go ahead and click Run and look at our output file just to confirm that we looked at actually both days here. So we looked at Sunday, difference between alcohol and ecstasy, and we looked at Wednesday as well. Got the p-values there, but if you want to drill down and look at the rest of the statistics, we could calculate effect size based on the standardized test statistic here. This is the first one for Sunday, and you click on here and you get the results for Wednesday. So on a Sunday, and for the small sample size, we want to look at the exact sig value. The exact p-value is 0.28, failed to reject. And if we click on the Wednesday data, again, as we discussed in class, the exact p-value is not 0, but it is less than these number of digits can display, so you'd report it as p is less than 0.001, which is the smallest value you can, smallest non-zero value you can indicate with these 3 digits. You have your population pyramid graph up here to show you the direction that things are going in, and we can look at these and conclude that folks who used alcohol on Wednesday reported significantly less depression than folks who had used ecstasy in the previous weekend. All right, that's it for the Mann-Whitney U. If we wanted to look at the repeated measure, right, so, and actually want to do this separately for folks who used alcohol. Let's go ahead and view our data labels. Folks who used alcohol and folks who used ecstasy. So I'm going to go ahead and split this so that we can see whether depression changed over time within this group of folks who used ecstasy. So that's a repeated measure. We would use the Wilcoxon signed rank test because we have 2 data points, right? And it's within subjects. But we're going to do 2 separate Wilcoxon signed rank tests by splitting the file by that grouping variable. So we're going to compare groups based on the type of drug they used. Click OK, and now we're going to choose the related samples from the nonparametric tests menu under the Analyze menu. Click on that. Again, skip to Settings, Customize Test, and we want to make sure that the Wilcoxon matched pair signed rank, and that's for 2 related samples. In this case, they're related because they came from the same person. And then when you click Run, we'll see what we got from that. Okay, so we did 2 tests, 2 Wilcoxon signed rank tests. The first one is for the ecstasy, folks who are taking ecstasy. Let's double click on that and see what the model viewer shows us. All right, here we plot grouped histogram with the ranks of the positive differences and the negative differences. Remember, there were no negative differences, so when we're subtracting your Wednesday score from your Sunday score, we get positive differences, meaning their scores were higher on Sunday. This is significant, right? So scores were higher on scores were higher on Wednesday than on Sunday. That means that folks were more depressed on Wednesday than we were on Sunday. Let's go back to the data file just to check that and make sure. Yeah, scores higher for ecstasy Wednesday than Sunday generally. We could do some descriptives just to confirm, but that's significant. We could plug in our standardized test statistic, divide by the square root of our n, that's the number of pairs of scores that we have, and get a measure of effect size. Let's go back and look at the results for alcohol. This difference is significant too, but we actually had more negative differences than positive differences. And that means if we're subtracting Wednesday minus Sunday, just as it says down here in the figured legend, it means that the scores on Sunday were higher than they were on Wednesday. So let's confirm that. Just eyeball the data here. Yep, scores were higher generally on Sunday than they were on Wednesday for most people. Okay, that means that although this is significant as well, the nature of the difference between your Wednesday and Sunday scores is different for alcohol than it is for ecstasy. So folks were more depressed on Sunday than on Wednesday when they had alcohol, and folks were more depressed on Wednesday than they were on Sunday when they used ecstasy. All right. Let's open another data file at this point. So I'm going to close the model viewer, and we're going to open the SOIA data so that we can look at independent groups test with more than 2 levels. All right, and this is the example that we looked at in class, but we didn't get to run it in SPSS. So we have 4 groups here, 0, 1, 4, and 7 soy meals per week, and we want to analyze those independent groups, look for differences among the independent groups. We're going to go to settings and click on customize tests. We want to do the Kruskal-Wallis. It's a one-way Anova for K number of samples. K is the number of conditions that we have. We've got 4. We're not going to do all pairwise comparisons. This time we're going to do the stepwise step down, and go ahead and click run. Alright, and this gives you your hypothesis test summary. Here's our p-value, 0.03, and let's double click on that to open it up. We've got box plots for each of the 4 samples, and we get our p-value, but no standardized test statistic. We'd actually have to work backwards from this if we wanted to calculate an effect size for the omnibus significant finding. We're going to go ahead and reject the null, conclude there's some significant difference around here somewhere. And if you view the homogeneous subsets, right, then it shows you that the group 7 soy meals was significantly different from the rest of the 3. These 3 groups together, these 3 conditions together constitute a homogeneous subset itself, so no significant differences among these 3. It says that here's your p-value that says there's no significant difference among these 3. The p-value that says that this one's significantly different from the rest of these, though, is not displayed. Because there's only 1 sample in this group, it's not displaying the p-value. Still trying to figure out why. Got an email into Andy Field. I hope he gets back to me. All right. Just a quick reminder, if we redid that, did that over again, independent samples, Kruskal-Wallis, and did all pairwise comparisons using the Bonferroni correction, it's going to adjust those p-values such that we still reject the null for the omnibus finding. There's a significant difference somewhere among these 3 groups, but if we view those pairwise comparisons with the Bonferroni adjustment, this one's close, but no significant differences among these four groups. Sometimes that happens. Okay, the last thing that we're going to do is open a new data file. This one's called diet. So if you open the diet data file, this is repeated measures data, but we have 3 different time points. So we're going to use Friedman's Anova to analyze that, and it can be found in the nonparametric tests menu. They're related samples. So these are 3 measures of weight at different times. There's a baseline, and then 1 month and 2 months after starting Andy's diet plan, which you can read about in the textbook. So related samples, just click straight through to the settings menu and click on customize tests. You want to choose Friedman's Anova by ranks. This is for K samples. K is the number of conditions we have, or the number of related samples that we have. We're going to go ahead and do the stepwise step down procedure, which it will only do if it finds a significant omnibus effect. And we'll see when we click run that the diet didn't work. There's no significant overall effect of treatment across these 3 time points. If we double click on it, we'll see these population pyramid, but over 3 different time points, and you can see that there's no significant difference among the 3 time points, and multiple comparisons were not performed. So we retain the null hypothesis, and that is it for the nonparametric analysis menu.